Kia ora, everybody. Thank you for coming along today. It's not Wellington's best day but, in terms of the weather, but it's very exciting to have you all here and have this event. I'm Danielle Aberdeen. I'm the Commercial and Sectors Manager at Standards New Zealand. And I'd like to start this session with our MB karakia. Tawhia tamana kia mau kia maia. Ka huri taku aro ki te pai kaharangi. Ke rera te auranga moko. Ma mahi tahi ka ora ka puai. A matu mahi katoa ka pono ka tika. Tihe moriora. I wanted to just share the translation of that because I think it's really important for what we're about to talk about today. Retain and hold fast to your mana. Be bold, be brave. We turn our attention to the future. That's where the opportunities lie. By working together, we will flourish and achieve greatness, taking responsibility to commit to doing things right. Tihe moriora. I think that's very fitting for the session we're going to have now for the next hour, talking about standards and digital innovation in building. So on behalf of Standards New Zealand, I'd like to give you a very warm welcome. You know, it's not that warm outside. I'll shortly run through the agenda, but just some quick housekeeping to take care of. The emergency exits, straight out the door you came in, and then straight out to the front through the main entrance that you came in. If there is an earthquake, we all know what to do. Drop, cover and hold, stay put until we all know the shaking stopped and it's safe to leave. Bathrooms, if you need those, straight out far end of the cafe there. There's both bathrooms there. Okay. Our online audience, please, if you have any problems hearing or viewing the screens, just wave your virtual hand. And we've got a team here that will address any technical issues. Okay, so it's great to see a lovely variety of people here today. Some from government, small business, across building industry, all with an interest in standards, digital innovation and building. Might seem like an odd mix, but we're going to put it all together and see what comes out of that. I'd like to extend that welcome, obviously, to our online audience, and that's just a wonderful example of how technology is making our lives easier and connecting us all. So a bit about Standards New Zealand, for those that don't know too much about us. We are a business unit within MB. We develop consensus-based standards, working with committees of experts. We also provide access to standards. And as New Zealand's national standards body, we coordinate the country's contributions to the development and review of international standards. Standards New Zealand, we're delighted to host this Tech Week event. We've got two today, so if you're around at 3 o'clock, you're welcome to come back for the second one. But Standards New Zealand has identified the digital economy as a priority sector for New Zealand. It's a sector where we see standards could play a potentially larger role to support the economy and New Zealand's prosperity. So moving closer on to what we're here to talk about today. Standards New Zealand aims to make standards more accessible and more able to be used in more meaningful ways. We want to increase their uptake and usefulness. So we're trialling new ways of accessing standards for users. This is looking at digital. Two things that we've got on the go at the moment, I just want to quickly share. We've just recently launched a digital reader product, and there's some flyers at the back, and I really encourage you to have a look at it if you haven't. It's a digital reader pilot. We launched in April, and it's available free to go in and have a play and a trial until September this year. It's potentially the future option for us in how we will access standards. We will always have PDFs and hard copies, so that's, don't get concerned that we'll take those away, but this is a way of having standards in your pocket, having a way to have them easily accessible anywhere, anytime. There's a whole heap of features in terms of being able to zoom in on diagrams, make notes, personal notes on them. So it's a very, very easy to use functionality, and we'd just really encourage you to try the pilot and give us some feedback. There's 5 standards currently available in that, and one of them is NZS 3604, the timber frames building. So have a look at that. The second thing is our value add program, which brings me to CAS and ACABIM. So our value add program is all about trying to make standards available in new and different ways, perhaps using just key pieces of content or key sections of the standard and making them applicable for real world situations. We want to improve on the book delivery solution and support innovative ways to make them more directly useful. So the Standards New Zealand Value Add program is a step in that direction. We work with third parties who can see potential for offering standards content in a different way. We make the standards content available, offering a supportive path and enabling how we use that copyright. And that's where ACABIM comes in. So it's an excellent example of what we're doing in our value add program, using standards content to create greater benefits for end users. ACABIM is at the forefront of standards-based innovation. It's world-leading digital technology designed to simplify complex building compliance audits. The ACABIM system is developed by Compliance Audit Systems, is set to revolutionise the building design compliance auditing, helping the building industry be safe, efficient and future-proofed. So I'm delighted to introduce you to Dr Johannes Dimyadi, the CEO of Compliance Audit Systems, and Professor Robert Amor of Auckland University, who are leading the development of ACABIM. They're going to tell us about ACABIM and give us a demonstration. Following that, we will have Minas Liarokapis, who is pioneering new robotics, technology and construction industry, and he's going to share his work with us. Minas is a senior lecturer, Department of Mechanical Engineering at the Faculty of Engineering at the University of Auckland. There'll be time for questions and answers following both presentations, and I really welcome questions. And at the end of today's session, there'll be some tea and coffee for anyone who wants to hang around and talk with the team here or with Standards New Zealand. Great. Over to you, Johannes.
Thank you, Danielle. So, tēnā koutou katoa. Good morning, everyone, and welcome. We are delighted to give you a sneak preview of ACABIM. So, cloud-based smart system for compliance audit and management solutions. And to kick start, I'm going to invite Robert Amor, one of the directors. He's also a professor in computer science at the University of Auckland. That will talk to you about problems we are addressing with ACABIM and how we solve them by leveraging on digital standards and regulations. And then I'll come back and show you the live, not live, but pre-recorded demo due to connectivity and of how it works in real time. And then Minas will join me afterwards to talk about the connection with robotics and construction, how software can instruct the robots to do work on the construction site. Robert.
Thanks, Johannes. Thank you. This is really quite interesting because this is an area, co-compliance checking, that has been looked at for almost 50 years internationally, and we really haven't found good solutions to this. We've been looking at this 30 years in New Zealand. So brands back in the 90s had the first project with the University of Auckland looking at trying to create languages so we could describe our codes and standards so that they could be computerized. And so 30 years later, we're kind of at the stage where we now have the technology, we now have the tools, we now have the models, which is going to make this available. So it's kind of nice to see that progression, that research that looked wild and wonderful 30 years ago actually coming to play nowadays. And so I'll talk a little bit about the current state of compliance audit. I think a lot of you will already know this, so I'm preaching to the converted about the processes, but just to highlight the approach and the issues that we have there. look at some of the international developments and New Zealand developments, which now make this possible for us to entertain the thought that we can check buildings against a portion of the codes and standards that we have. And then, as Johannes says, we'll have a look at our solution and a demonstration of how it works. So in terms of the current code compliance checking, as you know, as we go through the design process, we have the building plans, which are developed based on our understanding, designers and engineers' understandings of the codes and standards of the country, and they get submitted to a building consenting authority. And they will go through all of those, again, checking against our codes and standards to determine whether the building is satisfactory for construction. And as you know, if there are any issues with that, there's missing information, if there's insufficient information, then RFI gets generated, that goes back to the designers, the engineers. They have to provide the extra information. It goes back to the BCA, typically a council, to work on. And there's this long cycle of, often a long cycle of checking until we get to the point where it will get approved and you can start constructing your building. And so that manual process is reliant on understanding a large number of codes and standards, which are here in New Zealand and available internationally. The council say up to 200 codes and standards that typically used in assessing a building, a commercial building that they're looking at consenting. So the experts, many experts have to be brought in to do that assessment. And as I've shown, a lot of the work that they do is not really value-adding work. It's quite tedious and fairly simple checks that they're doing for much of the checking that they're doing. There are, of course, many much more complicated checks that should be done. And the approach that we have here is saying, well, you know, what are computers good for? Computers are good for doing the simple, repetitive things that humans are really not very good for. Currently, they're not very good at doing the complex calculations and applying expert knowledge to do assessments. So can we have a partnership between the human experts and the computer to be able to more accurately and quickly check the codes and standards against the building designs which go in? This checking happens not just at design, it happens all the way through the process. So as you're constructing, as you're looking at retrofit, as you're looking at demolition, there are compliance issues that impact on the building that have to be checked, that have to be ascertained. And as Johannes will show, the solution that we're developing will check compliance against the building at all stages of the life cycle. We'll focus more on the design aspects, but the ACABIM solution is there for all compliance checking across the life cycle of the building. So some of the issues that we see and that we're facing. So if we want to computerize this, well, we need regulations which are computerized. They don't exist. Our regulations are written for human interpretation and human understanding. And there's quite a difference between what we're capable of doing as humans and what computers are capable of doing. And so if we want to be able to computerize any aspects of this, then the regulations have to be turned into a computable form. And there's, say, quite a gap between the written version and a computerized version. And so how we make that change happen and ensure that they're correct is an issue if we want to move into automated code checking. I mentioned that the humans are doing very simple tasks often. You know, a room like this, occupancy level, yeah, over 30, does the door swing outwards? Okay, you have to check that for every single room in this building where the occupancy is great enough that the door should swing outwards. And so you have expert engineers who are going through the plans and running these very simple checks against trying to identify every room which has a particular occupancy level, checking what type of door is there and which way the swing is on that door. And this is something that humans are likely to get wrong. They might not find every single room which has the right occupancy level looking through all of the paper designs. And so they may miss some of these things. Computers, on the other hand, I mean, this is bread and butter for computers, you know, just do that check, you check every single room. And as long as the information is in the models, then you can apply the check, which makes sure that that's there. So there's a lot of tedious things which are happening, which we know computers will be really good at doing, but at the moment we don't have the codes in a way that we can run those checks. And we also know that councils interpret our codes and standards in different ways. So every council is in charge of determining how they do the checking of the codes and standards. And so there can be differences between the application of the codes and standards. Humans make mistakes, computers make mistakes as well, but usually we can fix those. But we want to find ways of making the trivial things much easier to do. So the approach that we're looking with ACABIM is very much computerized. So what we have is the building models that we're getting. We have building information modeling available to us, which gives us an electronic version of the building. And it's not just graphical information that we're getting all the attributes of the building. We know it's a door, we know which way the door swings, we know the materials of the door, we know if it should be a fire stop door. All of the attributes which let us do more complex analysis of our building is within these BIM models. And so we're getting this morass of information which is now useful for us to be able to apply the checks on them. We need electronic versions of codes and standards, and ACABIM and CAS has been working on a couple of government-funded projects and translating some of the codes and standards into an electronic version. So we have 15 done so far. I said 600 before, we've got 15 done. So that's really hard work. We're finding it's taking about a day of expert time to translate a page of a code or a page of a standard. So if you pick up 3604, you can see how much time that's going to be to do the translation into a computable form. But once we have those, we're able to associate the electronic version of the code with the building information model and perform the checks which need to be done. So this computerized audit process that we have is the core of ACABIM. We mimic the processes that the BCAs use, that the councils use. So we follow the same process that they use for doing that checking. We create process diagrams which capture exactly the same process they have, so that you have the same knowledge of how the checks have been done, that they've been done in the same way as the council would do them always, and you can go back and make sure that there's complementarity between their approach and our approach. We get the approval, we can go and construct. The nice thing is, RFIs should never happen because you know whether the information that you need to do the checks is in the model before you actually submit. So we can make sure that all the information that's required for that type of building, for that location, is actually in the BIM model. And so there should never be any need to go back and say there's insufficient information provided. There's not enough information there for us to do these checks. We can make sure that happens before the building model is submitted to the BCA. So as I said, there's a lot that we need to make this really viable inside the country. So the 43 technical clauses from the building code, up to 500 normative references from standards, not just New Zealand ones, but ISO, ANSI, and the Australian standards, all which are referenced that we need to be able to have access to be able to do some of the calculations that we're doing. Working with the council, we've done a lot of work with the Christchurch City Council. They've identified 15 to 20 of the codes and standards which they think are their priority for doing the checks. The majority of checks that they do on a building come from these 15 to 20 codes and standards. And so we've been trying to match that in terms of making electronic versions of those particular codes and standards that we can demonstrate where the benefit is in applying this approach. Talking about the standards New Zealand value add program. So this has been really useful for us that we can get access to these codes and standards. So the codes the MB has made available for the standards. We have to be able to incorporate those into ACABIM. We've joined up with the value add program to get access to those particular standards, and so computerizing those to put them into the ACABIM system. We're also, as I said, it takes a day a page. That's going to be millions of dollars worth of translation to try and get the New Zealand codes and standards into a computerized form. And we're sure that by the time we've done that, they'll change because they're always changing. And so once we've done our $6 million worth of work to translate everything into electronic form, we have to go back again and redo all of those codes and standards which have been updated in the meantime. Even the 15 that we've done now, 3 of them have changed since we've translated them. So we know this is going to be an ongoing process. So we're doing some research with natural language processing to say, well, how much can we comprehend from the written versions of these codes and translate automatically so that we don't take a day per page. Maybe we can take 5 or 10 minutes per page. That would be really nice, so that we can do this. So again, we have 3 of the standards being made available for this. A whole lot of the standards have been translated into electronic form, ISO STS form, and we have 3 of those available, and we're trying to work out how well our NLP systems can translate them automatically into electronic form. So still doing research to try and improve what we're doing with them. For CAS and ACABIM, we've chosen 2 representations, legal rule ML and legal doc ML. Legal rule ML gives us a way of capturing the rules, the formula which are in the standards, the tables, all of the things that we do make decisions on, can do calculations on, and put them into a form that the computer can recognize. The legal doc ML gives us the format of the standard, but they're very tightly coupled. So every time a clause changes in the written standard, we know where we have to update our rules. And for us, that gives us a really good connection between how the rules work and the changes, and making sure that we're always delivering the most up-to-date version of the standards. What we'd like to see, and we'll do a pitch, and I know in our constrained budgetary environments how difficult this is, but what we'd like to see is that there is a computable version of the standards made available for everyone in New Zealand. And we think that MB is the place that should be holding this in the same way that they hold all of the paper-based version of the standards, so that you don't get lots of companies like ACABIM, CAS, developing their own interpretation of the standards and perhaps getting 10, 20, 30 different interpretations of the same standard as each company tries to put that information into the tools that they're working. So we think that it would be beneficial for the New Zealand industry if there was one source of truth for the computable version of these standards, and that everyone could access that, whatever payment form terms there might be, that everyone could access that one source of truth and make sure that we're all doing the calculations in the same way for the tools that we're providing. So we could have the standards, we could have electronic forms of them. It's going to cost money. It will take a lot of expertise to get it in that form, and that's a conversation that we have to enter in as we develop our tool. The building information modeling, building information models, that's a bit more set because the international community has developed the standards in that area. The IFC standard is ISO 16739, and that is used by the majority of the BIM tools, or accessible through the majority of the BIM tools. And so we can get the information that we need about our buildings. We get far too much information, so 101 classes defined in those standards. So we don't actually need all of the information which is in that standard, but it does give us a way of getting all of the information that we want. And we know in New Zealand that is now possible. We're over 60% of the projects in New Zealand are using BIM in some form on those projects. So BIM models are available for the majority of the buildings which are being designed at this point in time. And so the councils are starting to think about what can they do with these models? How do they position themselves in the future so that they can work smarter and faster with these models that might be available rather than e-paper, which is what we're working on now. And looking at the benefits, the BIM Acceleration Committee in New Zealand has identified a large number of benefits from BIM, and so that really means that the uptake of BIM is accelerating over the years, 8% increase year on year, which is pretty good. And it is projected to be a $1 billion market in Australasia by 2024. So it's a pretty serious market that is developing around the BIM models. As I said, for ACABIM, we're talking human-guided automation. So we know that we can't do everything. It's performance-based codes in New Zealand. The performance aspects are really hard for computers to work with. The acceptable solutions, much easier. We really like, computers really like it when you tell us what to do exactly. And we can transform much of the acceptable solutions into a computation. The performance-based aspects, that's harder. that's where we see the need for the experts. And so ACABIM, as well as incorporating the calculations that it can do, has the ability to talk to simulation tools and run simulations, work out what the run an egress model to see how fast people can exit a building, to answer some of the questions that you might get in a performance-based code, or to call on a human and let the human do the calculations or make the assessment for part of the code. So for the bits that computers can do best, we'll do that. For the bits humans can do best, we'll let the humans work on that. As I said at the start, there's a whole range of processes where compliance is important. And so ACABIM is looking right at that life cycle. And as Johannes will show you in his demonstration, we have solutions which target many parts of this life cycle, do audit against the needs of each of those different parts of the life cycle. So we'll move very quickly into the demonstration that Johannes will give. The slide here just shows the interface into ACABIM. Looking at design, you can see that we have building models in here. So from IFC, we can bring in large and complicated building models. The Christchurch City Council has given us a number of large models to test that this approach will be capable of handling the types of models that they're seeing in Christchurch. So we can see large buildings, we can associate the land parcels for those buildings. And as you'll see here, this is the process equivalent of what the council would do to do a particular check against the code. And this is pretty much the engine of ACABIM. So this process enactment, which takes the right bits of information from the BIM model, the right clauses from the regulations, puts those together and does the right calculations on them to give us a result which says how compliant it is. And working with Christchurch City Council, we've been able to show that we can generate reports very much the same as the reports that they would put out when they're doing code compliance checking for a building. We find more things that they do. So computers are a little bit silly. If the tread riser is a millimetre off, it'll tell you it's a millimetre off. And a human expert wouldn't really worry about that. So we know, we're very exact. We have to build in a bit more human expertise into the assessment that we're making, so that we allow some of the things that would normally be allowed by a human, even though it's by the standard not exactly correct. But we generate reports so that people can see where the issues are with the system. So I'll hand back to Johannes and he can show you what it looks like.
Thank you, Robert. Right. So here's a sneak preview of ACABIM. It has 6 solutions for its phases of the project lifecycle: planning, design, construction, operation, the retrofit. And let's look at ACALand. So this is the ACALand where you can choose a site, your project, and then you can look at the land information and property information that we draw from links and various sources. And we can also query planning rules, depending on such as maximum parking rate for the site, which is already being pre-translated to legal ML. We can also look at optimizing site development based on some financial model and planning rules. You can select a zone and download a preliminary report that you can customize further. So this is just a quick look of the report is generated. Very templated format, very nicely done, but just a draft that you can customize. So let's move on to ACAPlan, which is next phase, where you can assess your concept.
Excuse me,
Sorry.
could you just share your
Oh,
screen
sorry.
with the online audience?
Yeah. Right. Sorry about that. Yeah.
Quickly do a quick recap.
Yeah, I could go back.
Cheers.
Another one, 50 meetings. Let's start again. Share screen. Okay. Right. No, it's this one. Yeah. Oops, another one. Sorry about that.
It's okay.
Okay. Yeah, perfect. All right. So let's quickly recap. So this is Akabim, 6 solutions for different aspects of a project lifecycle: planning, design, construction, operation, and retrofit. And let's look at Auckland to start with. So where you can select a site and a project, and you can look at the land information and property information that we draw from links and other data sources. You can also query planning rules that has been pre-translated, depending on what you want to look at. In this case, such as the maximum parking rate for this site. And we can also look at optimizing your site development based on financial model as well as planning rules. And from Auckland, or if it's like a zone, we can generate a draft report. A draft that you can customize to suit, but at least it's a nicely templated, nicely written report you can customize with all the information that you collected already included in the report. Now, Land goes on to Plan, where you can assess your concept design for more planning compliance assessment. And you can look at various aspects of the model and look at various information from the BIM model, the land parcel information, and also generate a planning report depending on the aspect of the checking. From Plan, we move on to Design, where you can select a BIM model and do more advanced compliance checking and computations. I'll come back to Design later on to show you a bit more on how we audit the building for compliance with digital standards and regulations. So this is just to show you how we can. So, but if a building, let's say this particular model has been approved for building consent, we can simply approve for construction that moves that project to Cons, which is the next phase in your life cycle. Simply click on proceed and it will go to Cons. So in Cons, you have access to that same model that has been moved from pre-construction to construction. And you can see there, work orders assigned to robots. That's when Minas will show you how that will happen. And from Cons, there's a quality assurance processes that you can go through. This is the human input side of Akabim. This is also generated by workflow that it can easily be customized. This example is a pre-line inspection. They can go through each one and customize to suit your project needs. There's a lot of work need to be done still, but this is a good start. And we can also move this project to handover to operation by moving the phase to FM. And this is FM, where you have the as-built information available to manage through the core work order management module. And you also have a set of preliminary asset register generated from your as-built information that you can develop further and manage through your asset management of the building. And then this is building component assets as well as assets introduced to the building post-construction. Now, Retro is part of building operation, where you can assess cost benefits of asset renewal or disposal. And it can be done simply by Q&A generated from workflow, or some computation models that we eventually will build into this to do computation behind the scene. And in this case, if we determined to refurbish the building, we just simply move it back to Arkansas. And the model will become available again for design. So now let's look at Arca design, where I'll show you how a building is actually audited based on, so let's select an office building, which is a 4-story building, and run through a workflow. So there's a building model. And let's pick, so we can look at the building model and the building information from the model. We query the spaces, the walls, and this is all the information contained in the model. Now let's pick a workflow. It's on the way. We just check doors of spaces. So as you can see there, there's a violation. Now, this is querying CAS2 document to make sure doors are swinging in the right direction depending on the occupant load of its space that Robert briefly described earlier. So if you look at that, so basically taking criteria from that document and check for occupant density depending on the activities of the space, and calculating or estimating the potential occupant load of the space. In this case, is space 308. There's 148 people, and door count violated, door opening direction violated, because it requires 2 doors and it's only 1 provided, right? So we can look at the building plan and have a look and see what's going on there. So you go to the floor plan generated from the building model, go to that space, and you can, as you can see, the door actually open inwards. Now let's, you can also generate a report of the execution result. As you can see, a lot of calculation behind the scene, with just such a simple result. So you can produce a detailed report of the execution. And let's pick another one. Let's look at a calculation process where this is based on CVM2 verification method. For a calculation method to determine how long does it take for fire to break out of every room is a very computational intensive that fire engineer has to do on a daily basis. If you have hundreds of rooms, you probably have to do this quite a long time. But people can just quickly run through that process and give you a result, just like that. So another one, what about check if lift is needed in this building? So run through the process. Now this is based on NZS 4121. There's a flow chart in NZS 4121 to guide you through the checks to see whether a lift is required. And in this case, it says lift is required because one of the criteria is satisfied with this building spread in 4 stories. What about natural ventilation to G4AS1? If this building was designed for natural ventilation, then we want to know whether they all comply based on the criteria of ratio of vent opening to floor area. In this case, is 0.05. And as you can see, there's 1 violation there as well. And we can also query to see what's going on there. So obviously the ratio is less than the criteria. And we can send this data through to another system to integrate with another system if necessary. So the JSON data exchange is open standard. We can exchange with other systems for other purposes. And let's pick another building to look at and run through one of the checks as well, which is this is a simple one building with the mezzanine floor. And let's check if a lift is required in this building. So let's run through the same procedures. And the result is lift is not required. Why is that? And see here. It says there are 17 spaces on second top story. Total occupant load is 23, which is less than 40, which is the criteria. And that's it. So that's a quick sneak preview on how it works. I'd like to invite Minas now to show you robotics. Yep. It is. Minas. Screen share, it's still sharing? Still good? Excellent. Skip. It's not almost battery is almost run out. This. Yeah, okay. Yeah, need to be updated. Thank you.
So I will start talking a little bit about my research, what we do in the University of Auckland, and then I will try to connect my work with the work of CAS. So I will talk today about intelligent collaborative robots and how we can use robotic technologies in order to create high quality affordable houses. I don't know. Hi. Great. So as you all probably know, we have a housing crisis. What are the problems? We have a lot of homes that lack proper insulation. They are not of appropriate quality. We have a shortfall of houses. We need more houses, more affordable houses, houses of better quality. We need new solutions for the rapid delivery of high quality affordable houses. And the crisis, the housing crisis, affects disproportionately Maori and Pacifica communities. What we are trying to achieve, we want to create the hardware, the platforms that are needed in order to automate construction. And we also want to create new human-robot collaboration frameworks. We need to facilitate robots to work together with humans in construction sites. And these technologies are expected to facilitate the fabrication of both off-site and on-site components of affordable houses. So we work on prefabrication, but we also work on on-site construction. This is what you see if you visit the new factory of Fletcher building. Fletcher has invested a lot of money into creating Clevercore. Clevercore is a new factory that is supposed to automate prefabrication. But still, you see human workers doing a lot of manual tasks. The level of automation is not quite there yet. We need to increase automation. We need to increase speed of construction. And we need to help companies like Fletcher, but also New Zealand SMEs, to increase their productivity. What we want to achieve, we want to move from this image to this image. We want humans and robots working together. And by together, I don't mean that the human supervisor tells to the robot what to do. No, we expect them that they will work next to each other. Why? Because robots are not ready. A lot of people are talking about robots coming and taking the jobs of people. Robots are not ready. We need another 20 or 30 or 40 years to reach the dexterity of humans. You see here an anthropomorphic, a human-like robot hand that mimics my right hand. We can do a lot of testing, and I can prove to you that my dexterity cannot be matched by robotic devices. So humans are dexterous. Humans can achieve a lot of things that robots cannot achieve. But robots are reliable, fast, and they can work 24/7. And we plan to use robots not only on on-site environments, but also not only off-site in prefabrication environments, but also on-site. And on-site, it makes a lot of sense for robots to handle dangerous materials, or to carry heavy loads, or to do things that are dangerous or boring for humans. So what we are trying to achieve, we want to improve job satisfaction of construction workers. We want to upskill construction workers. And we want to make construction workers and robots together more productive, and therefore New Zealand companies more productive. This is how it will work with the CAS software. You see here that we have work orders that can be assigned to humans and work orders that will be assigned to robots. So you have a workforce of humans and robots working together. And if we go to the work request of robots, you see here the building, the site, the floor, the type of work, and the assignments. And you can really explain to the robot what it needs to be done. 5 o'clock you leave, the robot takes over. And the next morning, a lot of things have been accomplished. Now, you get the idea of what we are trying to do. Let's talk a little bit about the technical solutions, about the engineering solutions. First of all, we need to develop new robot hardware that doesn't exist. This is an example of a robotic hand that we developed in the University of Auckland. This is fully fabricated in New Zealand, and we can use it for AROA. AROA stands for Autonomous Robotic Assistant. In Maori, AROA means perception. And AROA is expected to be a platform that will provide a lot of derivative platforms for the different tasks of the construction industry. So AROA is the superset. AROA is the dexterous platform. And from AROA, we can derive a lot of simplified versions of AROA. Here you see my team and me together next to AROA. AROA is taller than me, 270 kilos, and it can carry 100 kilos of weight. It is equipped with this robot hand that you can see. Let me give it to you in order for you to take a look. Yeah. And also, it is also equipped with special tooling. These special grippers and tools can allow for drilling, can allow for assembly, can allow for installation of insulation or of cladding. And here you see how the coordinated robot motion looks like. In this video, we use two of these hands that you can see here today. Or we can also use them for construction tasks like drilling. The other important part of our work is once we have developed the hardware to create new human-robot collaboration frameworks. And in this domain, we need to make sure that the robot motion will be predictable. We don't want the robot to move in an arbitrary manner because it may hurt people. So we need to guarantee that all the control and path planning schemes that we will use will be safe for interactions with humans. And we want to make sure that all robot motions are predictable, or all robot plans are predictable. We use augmented reality. Why do we use augmented reality? Because AROA is equipped with a lot of cameras. As AROA moves within a room, it reconstructs the environment. It creates a digital twin of the construction site. And the digital twin of the construction site updates the model in the software of CAS. Now, the human can enter the model with augmented reality or virtual reality and can annotate the model. So the human goes to the new augmented reality and describes to the robot what needs to be done next. For example, it annotates this wall and instructs the robot to construct the remaining wall. The beam models are updated from the data that AROA collects, and all the processes within the software of CAS are updated. And the fun part is the skill transfer. Because as we discussed, humans excel in executing complex tasks. Human workers may have 30 years of experience completing specific tasks. So what we plan to do is to ask human expert workers to teach the robots how to accomplish the tasks. So the robots watch humans and replicate. And here is an example. The humans move the robots and teach the robots the task. We can do that with kinesthetic teaching. Kinesthetic teaching is when you grab the robot and you move it around in space. Then the robot, from the blue line that was taught by the human, creates the red line, which is optimized. So the robot takes the demonstration of the humans and optimizes it. Here we use another teaching example where we teleoperate the robot. We teleoperate the robot from a distance in order to execute a task. And we have the blue demonstration, the blue line. Then the robot takes over and optimizes the blue trajectory that was instructed by the humans so as to be faster, more efficient. And you can have, on average, 17.5% shorter trajectories and therefore increased productivity and increased speed. we work with a lot of people from across New Zealand. Right now, we are discussing with teams from 8 different universities and research institutes. We have discussions with 13 companies that want to be involved in this line of work and 8 community partners. And we have created a research group that all of them together, all the academics, they have published more than 2,000 publications, attracting more than 100,000 citations and 100 million in funding from New Zealand and overseas. And we expect that this team in the future will be able to deliver impact in the following form. We want to increase New Zealand exports in the construction and manufacturing sector. In order to give some context, the industrial automation market is expected to be $280 billion by 2025. And all the robots that we want to build for construction can also be used for industrial automation. So the hardware is the same. We want to improve the construction sector's productivity through the hardware and the new human-robot collaboration frameworks. We want to allow New Zealand companies, and not only big companies like Fletcher, but also local SMEs, to be able to reconfigure the product lines, try new business paradigms, try new business opportunities, and reconfigure their production capabilities on demand. This is what this kind of work allows. We want to investigate and address the social aspects because we all know that automation is coming. And we believe that if we start working on that before it comes, then we can influence policies. We can see what the impact will be on the workforce, how construction workers perceive the changes that are coming, and how we can create new upskilling opportunities. And we want also to upskill the construction workforce in order to be ready for the future, in order to be future-proof. And by upskilling, let me clarify this because I get this question a lot. We don't expect that construction workers will become programmers. Some of them may think that programming is boring. Some of them chose construction because they like the hands-on activities of construction. As you see, with the kinesthetic teaching, they retain the physical interaction. They collaborate with the robot, but they collaborate with the robot as they would collaborate with a human co-worker. They carry things together. They teach the robots how to do the complicated things that they want to do. More information you can find in newdexterity.org, the website of the team. Thank you very much.
Thank you, Johannes, Robert, Minas. I think I speak to everyone here. That's very, very interesting and really exciting about the potential that both these have, but then when you put them together, what it means for productivity, safety, job satisfaction, the social impact. Yeah, very, very exciting. So thank you for sharing it with us. I'm very conscious of time. We were scheduled to finish at 11 and tea and coffee will be coming if anyone wants to stay back. But do we have any quick questions or run through questions? Yes.
Yeah, hi. So at Peppercore, Weinman has put in that equipment there, right? The double power stable automation. But if we look over scenes, we actually see that they've actually got robotics that are doing the jobs of what you showed on the video there. What's the difference? What are you guys doing in your team that is different from what's happening internationally?
Yeah, overseas, what they do, they buy very big structures, automated structures that automate part of the factory, carrying materials to these machines and taking the processed materials from these machines to another part of the product line is not fixed.
Right.
The other problem that we have with these machines is that they are huge. Only Clevercore or Fletcher or the big guys can afford them. What about local SMEs? Do we care only about the big companies? If yes, then these solutions solve part of the problem. But if we want also to increase the productivity of local SMEs, then we need to start discussing about solutions that will offer good ROI, return on investment. And these are not the solutions that other people overseas are using. And they are huge. If you see such a factory, you need a factory like Liverpool, a huge factory. How you can have such a factory in Auckland with the land prices?
I've used the biggest indoor system, indoor unit you can get.
Sure.
They should have done.
Sorry, I cannot hear you very well. Could you please repeat that?
Run.
I think I understand what you're saying. You're saying that you're looking more towards distributed
Yes.
automation and manufacturing, so that you can actually get something out in a unit, and then by programming, you can actually incorporate multiple tasks.
You can refer.
Than like machinery.
The two words that I use is, the one word is ultra flexible. That means that you take it and you do whatever you like with this platform, and repurposing. So you can take the same platform and use it for a completely different application.
So the sort of limitations I saw, or rather the things that I saw with the robotic hand, and you're talking about dexterity, is that in construction, I tend to think that they are quite simple processes. You know, like, I mean, you don't need a robotic hand to hold something while you're drilling. And, you know, I mean, I sort of see that things are quite simple here, really. But I'm guessing also you're looking at, if you add this to the likes of drone technology, then all of a sudden you can get access to places that you wouldn't, that would be difficult, and you could incorporate a whole lot of other things for more probably maybe rather when things go wrong. Is it that?
Construction right now, it has simple tasks because we construct houses like that. If we change the paradigm of how we construct houses, then you can need more dexterity. For example, I work with a company now to automate routing of electrical cables. Routing of electrical cables needs a lot of dexterity. And we are trying to do it with robots. It's not as simple. Humans can do it better, but we are getting there. This robot, the multi-purpose robot, the human-like one, is not needed in most tasks. In most tasks, a gripper or a simple tool is sufficient. Why we have it? Because it gives you general dexterity that can be adapted to the needs of SMEs. I have an SME that I'm talking to in Nelson that focuses on timber structures that wants to automate parts of the factory. You cannot accomplish that with special tools. You need some general gripper that can do multiple things with the same hardware.
I have a question just
Yes.
on the robotics side of things. So, because the machine is a tool, right? And it's not the brains behind it, it's a human. So how do you guarantee making sure whatever the machine does is actually New Zealand Board Code compliant? What's your QA? What's the QA process for it?
Yeah, we have a lot of human to robot skill transfer frameworks that rely on analytical models and machine learning synergistically. We use analytical models because they give us certainty about the behavior of the robot, and machine learning in order to predict new behaviors and adapt to new environments. And these human to robot skill transfer frameworks, they take the human motion and they map it to compliant robot motion. And by compliant, I mean in the sense that it needs to be safe, it needs to guarantee execution, it needs to guarantee that the productivity will be increased. So we have all the theory. I didn't discuss today, but if you are interested, we can discuss it offline.
Are there any more questions? Steve?
In regards to the CAS, what's the BCA approach into that? Are they accepting what we're trying to do?
Yes, we got some very strong support. And we've done 3 case studies with Christchurch City Council, as we just explained earlier. And so the case studies that we've done with Christchurch City Council, I think they came back with about 30% saving, including the learning curve to use the software.
But are they accepting a lot like the final reports which will generate, which will say something's in compliance? And
Right.
That full chain of compliance, and then goes up through BCA to the bodies that accredit them as well.
Yep, thank you. So, so the goal is not to provide full compliance, like the whole way through, partial aspects of compliance. And there's still a lot of conversation that need to be done on that. Yeah.
I guess their timetable to introduce this technology is still, over the next 5 years. Council, you're from the council here. Councils don't move
I think
that
we've got
fast.
someone from the council.
So very, very hard for a council to move within 6 months or 12 months. And so the planning for introducing this technology and accepting BIM and knowing how to store it and process it requires a considerable period of planning for the council. So it will be future, but hopefully within 5 years future.
Hi there. So 3D printing of homes is now out there in terms of technology. Do you see this this adaptive robotic hardware interfacing with 3D printing technologies to produce a complete home?
We don't believe in 3D printing of homes. I don't think that it's a reliable solution. It's very good for headlines. It's very good for marketing reasons to say that we do 3D printing of houses. But if you want to deliver impact, it's not a good solution because you need to integrate a lot of materials. Houses are multi-materials. 3D printing, multi-material 3D printing is not even solved in research. We don't have the technology for good multi-material 3D printing. We may have it in 50 years. Today, it's all about headlines and good marketing.
So there are masonry produced skeletons of houses that are done through 3D printing. Are you saying that's not?
They're not of the quality that you need. We're talking about high quality housing here, not just fast housing. You can do fast housing with 3D printing, but will this last an earthquake? I don't know. I wouldn't live inside the 3D printed house. No, I appreciate that a lot of companies, a lot of startups are pitching 3D printing as a very good solution. I completely agree with them in 40 years or in 30 years. But we need these solutions yesterday.
Right. Is there any more questions?
So just with your software that you show with the AC BIM, who's the user of it and how? Because who's behind the software, and is there any competency that because anybody can run? Well, I want to say anybody, not anybody can run it, but like, how do you know they're competent enough to do the right input?
Right.
So who would just be using the academic system?
Yes. So in general, the users are individual practitioners, architects, engineers, as well as building concern authorities, consent processing authorities. Now, so how do we guarantee? Is that what your question was?
No, how do you ensure the user of, even if it's like an interior design or BCO, it doesn't matter, like how do you know they have the competency to actually make sure use the tool correctly? Because anybody can sit behind a computer.
Sure.
But the input, because the computer does the processing, but the data may be completely incorrect, then your output then it's incorrect.
Excellent question. I don't know the answer. So it will be a lot of training, obviously. Yeah. First of all, building consent office at the moment don't have full capabilities in processing a BIM model, right? So unless I'm wrong.
No.
Yeah. So that has to happen first, right?
Yeah.
Let's just jump in there. I mean, that's the value of having the likes of Robert involved from the University of Auckland, where we have a lot of workforce development and practical training programs that go alongside particular innovations?
I guess we already see that the BIM models are not sufficient quality at the moment. You know, so a lot of what we have to do in ACABIM is actually do some of that checking of the BIM models to ensure that they are passing us the right information, or that they haven't classified the spaces correctly, or they've used different classification codes than they should. A very simple quality control which needs to be put in, and so we don't think should really be our job, but at the moment we're seeing that that's a necessary part of solutions in this space is that guarantee of quality, and we're looking at ways that we can check the quality to make sure it is enough.
Yes, last question.
Will you ultimately be looking to integrate ACABIM with BIM software so that you get real-time auditing as you design?
Great.
Yeah,
Yeah.
that would be excellent. Yeah.
So looking at how we turn it around to the architects and engineers, that would be the platform that would make most sense. So it would be an add-on to Revit that you could call, and you could give yourself the assurance that you're meeting the checks that the council would make before you submit the plans.
And also maybe you'll be able to process and get mass amounts of data back as well on even just sort of the challenges and the inconsistencies that we currently have.
Correct.
And our auditing.
Yeah, as we speak, we actually just about to release an add-on to Revit that allows designers to behind the scenes processing the right information, so that when they export out to IFC, we get the right data. So we actually about to release that.
Okay. And then
But you're right, for councils, that they could tell, they'll know what types of buildings are coming through, what materials are being used, where the common faults are, it's in terms of education back to the industry of what is going wrong. There's a lot of data mining that we'll be able to do once we have those BIM models and this sort of checking to say what is the state of the industry and how do we improve the industry as well.
And then certification of the software. I imagine there are certification schemes. I think there's some in the UK maybe to actually have your software certified.
Yep.
So that users know that the algorithms and what sits behind it is actually doing what it needs to do.
So we support all open standards. So the workflow is BPMN compliant, and that can be verified independently. We use an IFC, which is ISO standards that can be verified independently. And the only black box is how to process those information together. And in my side, digital regulations actually is an open standard, legal OML that sits outside the system, so that can be verified independently.
Great, very interesting. Is there a question online?
One comment from Andy Lee. He says to answer the question from CCC.
Yeah, correct.
To get ACABIM results and trust it as being compliant, the biggest hurdle will be the accreditation. We'll need robust QA and procedures in place for IONS to pass our accreditation.
Thank you, Andy. Good to hear from you.
Great, well, we'll wrap it up there. I really appreciate everyone coming along today, and Minas, Johannes and Robert. We'll be around for another 20 minutes or so. Welcome to take questions. I just wanted to quickly introduce two people in my team, Ewan Heron, our Access Account Manager, and Frank Till. Frank, we'll wave out. If you want to have a chat about our digital reader product or value add, we would have a chat too.
Thank you for coming.
Thank you.
Thank you. Thank you, Dan.